Hi guys, hello SAP community and welcome to our SAP Community Call today. I'm happy to see you all here. That means that you all accepted the challenge. So this call is all about the SAP HANA Graph challenge and how you guys can gain hands-on experience with SAP HANA Graph. I'm Lena from the SAP community team and I'm moderating this call today for the SAP HANA team. And I'm joined by colleagues, Markus Fath and Umang Rawat, who are our SAP HANA Graph development experts, who will give you examples, who will give you use cases and the specific benefits of SAP HANA Graph throughout our 60-minute SAP Community Call. Markus will start with the first 25 minutes, half an hour to give an overview, and then Umang will continue with the SAP HANA Graph challenge. The Q&A is also here in YouTube after Umang and Markus' presentation, and we'll have the Q&A in the chat. So therefore, everyone should be logged in to ask the questions, because we have enough time towards the end to address all of your questions. The SAP HANA team already published a blog post in the SAP community about the challenge, which is added to the YouTube description. So go check that one out. And we have support by the SAP HANA team, of course, Shabana here also on the call, and Jörg from the SAP HANA team to answer questions in the chat. With that being said, I'll hand over to Markus to get started.
Yeah, thanks for the introduction and welcome to the session. I will share a couple of slides introducing the multi-model capabilities of SAP HANA Cloud before I hand over to my colleague Umang, who give you a little bit more challenges on the actual information on the challenges that we actually set up for you. We will be looking, of course, specifically into the graph, that means network capabilities, and the spatial capabilities of SAP HANA Cloud, because these are the features that you are going to be using to solve the challenge. Okay, so I guess most of you already have seen this architecture slide. And basically, it is about the smart multi-model processing capabilities that you see highlighted in the middle, and which stand out to some extent if you comparing the SAP HANA Cloud Data Management Platform, let's say, to other relational databases. In specific, we're talking about capabilities like predictive modeling and machine learning. So technically speaking, about the predictive analysis library, PAL library, which gives you some statistic and machine learning algorithms that you can use directly in the database. Besides natural language processing capabilities, including text search, text analysis, and text mining capabilities, we are also supporting the spatial capabilities. That means you can handle geometries, points, and line strings and polygons directly in the database and do very nice things. And besides that, HANA also has a native graph engine component, which allow you to expose or work with your data in a network-like manner and running some network analysis processes and pattern matching queries. So in a little bit more detail, we see that there is support for spatial graph and also the JSON document store. These are the core capabilities of our multi-model features. Spatial, as said, comprises spatial data types. So these are first-class citizens. These are data types like string data types or other numeric data types. And of course, they bring along their own spatial functions and how to deal with geometries, how to evaluate geometries and stuff like that. But having these capabilities in HANA is nice, but what you also need is a way to consume them, a way to expose them to the outside world, to the actual users. And there are a couple of ways to do that. Of course, there is the developer community working directly with the database, but from a consumption point of view, we do see that there are data scientists working with Python and Jupyter notebooks all day long. So there is a nice Python API also to work with these spatial capabilities. And last but not least, there is a wide variety of so-called GIS application, geographical information systems. So Esri is one of those vendors in that area, but there is also open source alternatives if you want to bring your spatial data on a map. Looking at the graph capabilities, it's all about exposing your data as a network. So think in terms of nodes and edges, vertices and relationships. And usually there are two types of workloads related to graph capabilities. One is more declarative, a little bit pattern matching query, where you're essentially looking for subgraph patterns which you would like to find in your graph. So a person named Fred connected to another person living in France. Think of that, these examples. Most notably, the SAP HANA Graph engine provides a programming model to write database procedures specifically tailored to that graph data model. So exposing graph vertices and edges in that programming model and a set of built-in algorithms. To round off the multi-model capabilities here, I mentioned the JSON document store. It's an alternative store to what we usually have in tables. It allows you to persist JSON data and query it from a SQL perspective. All of these are core capabilities of SAP HANA Cloud, and they are embedded into that context, which I already briefly mentioned. So different types of people working with a database, either bringing in data, if you are a data integrator, using our modeling and developer tooling in order to bring in the database artifacts and create procedures and functions and stuff like that. Then there are the data scientists living in Python, most of all, which use the machine learning Python API in order to work with the database artifacts and the built-in algorithms. And last but not least, there is that application perspective. And again, to mention here, for example, the GIS client being one of the consumption channels. Looking a little bit more in detail at the spatial core capabilities. So at the heart of the spatial engine, there is support for the spatial data types, which comprise points and line strings and polygons, usually representing real-world things like locations or streams or administrative boundaries. Usually these geometries are embedded in a two-dimensional surface, so the surface of the Earth. And as such, they are then always embedded or associated with a spatial reference system. If you're just using Google Maps and things like that, you might be familiar with some of the geographical reference systems and know some of the spatial reference ID like 4326. Which is a very prominent one used by the GPS system, for example. But there are many specialized spatial reference systems. If you're working with local spatial data, we all support that. Then on top of the data types, there is a set of over 150 spatial functions and predicates, which allow you to evaluate the spatial data. So there are Boolean operations, which allow you to check if two polygons, for example, intersect. Or you can query the relationships of certain geometries. You can ask if two administration boundaries, for example, touch each other. Then there are some property computation functions, for example, to evaluate the length of a line string in meters or the area of a polygon. From a consumption perspective, okay, I already mentioned the Esri ArcGIS set of products. Esri is a very strong partner of ours, and all the Esri products and applications are running nicely on top of the SAP HANA Cloud database. But there is also open source alternatives like QGIS, GeoTools, GeoServer, and stuff like that, for which we all have a decent amount of integration. Talking a little bit about some of the use case patterns that we do see. So sometimes it's merely about detecting spatial relationships, so checking if a customer location is within your sales region, if you're looking at it from a spatial perspective. Then there are a lot of use cases concerned with aggregating data along spatial dimensions. So understanding the density and the distribution along, for example, spatial grids, like you see here in the picture on the right-hand side, spatial clustering, understand how many observations, in this case of ships and ships traveling on Lake Michigan, are there over a certain period of time. Looking at movement data, for example, again, ships or cars traveling along roads or lakes, we do see patterns that deal with trajectories, so trips, routes of moving vehicles, and trying to understand these routes, how routes intersect, how the motion statistics are distributed. Think of speed and things of that nature. Last but not least, we see the spatial engine being used to derive spatial features like location characteristics, for example, of houses and stuff like that, and use these spatially derived features then in standard classical machine learning algorithms, for example, for categorization and forecasting. And let's switch over to the graph component, which is native to SAP HANA Cloud. We do support so-called labeled property graph models. That means your network is made out of vertices and edges. Think about persons and their relationships to each other, or think about companies and their relations and their products that they produce and stuff like that. Labeled means that the vertices as well as the edges can have an arbitrary set of attributes. So for persons, there may be first name, last name, birth date, and stuff like that. And for the edges, there might be, for example, a validity date. These are the labels to the property graph. It's directly embedded in SQL. So basically, the graph engine component pulls its data from standard relational tables, representing them as a network, and then providing specific network algorithms and query possibilities on top of that graph view on your relational data. I already mentioned pattern matching queries, so looking for a subgraph in your data graph. So for example, a person named Fred connected to another person living in France. These pattern matching can be expressed in a language called Cypher, which is put forward by Neo4j, one of the leading graph databases. Next to pattern matching, we do support a set of built-in algorithms that allow you to evaluate, for example, a shortest path between A and B. And surrounding these built-in algorithms, we offer a full-fledged programming model called GraphScript. If you're familiar with database procedures on relational data, if you're familiar with SQL script in SAP HANA Cloud, so GraphScript is the analogy on top of network data. From a consumption perspective, there is also a Python client, so the HANA ML library, which allows you to tap into the graph engine, create graph workspaces, and run some graph algorithms. And there is visualization capabilities provided by our HANA Database Explorer, for example. One of the roadmap milestones that we still have on the list is supporting graph processing, so the graph engine on top of your data being stored in the HANA document store, so your data being stored in JSON format, which is one of the upcoming features that we want to support later this year. Looking a little bit about into use case patterns, what we quite often see is things related to identify dependencies, doing some tracing. So if you think about a bill of material, so the structure, how your products are made of, so raw material being manufactured into half-finished goods and then into finished goods. what we see in that bill of material doing a where used list or bomb explosion as it's called. So for example, starting at raw material, show me all the products where this raw material is part of. This is identifying dependencies. Then there are a lot of use cases related to finding paths or doing reachability checks. So one of the examples here is route finding in open terrain. So in contrast to when you are traveling on a road network, where it's pretty clear on how you go and it's pretty clear on how you find the shortest path between two locations. On open terrain, there is it is a little bit of a more complex question. So usually you put a cost function on top of your terrain that you are routing on. So for example, you're saying, I can't go through water and I would like to avoid, let's say, huge vegetation because I can go there, but still every direction is possible. And picture showing you how to find paths on an open terrain. So that one in the middle, where you see essentially the digital elevation model and the path in between. And you would like to avoid, for example, steep slopes if you're going from A to B. Then there are a couple of things related to detecting cycles in your graphs or ordering the graph in a topological manner in order, for example, to calculate cost in a production run. So you're bringing your data into an order and then you're propagating certain costs, be it material costs or transportation costs or manufacturing costs. You're propagating these values in order to do a costing runs for your finished goods. Then there are a couple of scenarios related to analyzing flows. Where does money go, or where does water flow, and stuff like that. And an example is here on the right-hand side for flow analysis. If we look at a water network, in specific a stormwater network, and you're asking yourself, okay, if heavy rain is hitting that network, where are the bottlenecks? Where is my network most likely to run over out of water? Then there are a couple of use cases related to finding most important nodes in a network. So these are related to centrality algorithms. For example, finding influencers in a social network or finding certain areas in a street or transportation network, which are very critical to that infrastructure. That means if they fail, a lot of people have to reroute or take deviations. And last but not least, as also in the case of the spatial engine, people are using the graph engine to derive certain features, which they then use downstream in standard classical machine learning algorithms. Now, looking at this a little bit from a technical perspective, I already mentioned that the graph engine component in SAP HANA Cloud sits on top of relational data, sits on top of tables. So you see the tables depicted on that slide. So the yellow table down here contains the vertices information. So we do see that there's Fred and there is SAP being of type person and organization respectively. The blue data structure, the blue table exposes the relationships, the vertices in between. And everything that you need to do in order to enable the graph engine to run on top of that data is you need to define a so-called graph workspace. It's a small metadata object which simply tells SAP HANA, hey, where are my vertices and where are my edges? So you're creating the graph workspace, pointing to the edges data structure, pointing to the vertices data structure, and then you can use pattern matching queries and graph algorithms. I just mentioned that the data sources are data structures. In most cases, these are tables, but you can very well use, for example, SQL views in order to project your data into the right format, being vertices and edges, and making that consumable to the graph engine. And you can even use table functions in order to prepare your data and expose it to the SAP HANA Cloud Graph Engine. Here is an example of a pattern matching query or how that looks like. The query language is called Cypher, again brought forward by Neo4j. We do support Cypher for pattern matching queries, and essentially Cypher queries look a little bit like SQL. So at least there is a where clause and there is something like a select clause, which here is called match. And the match clause basically lets you describe the structure, the topology of your query graph. So in this case, I'm looking for a person which is connected to an organization by an edge which is labeled works for. So I'm looking for that pattern that you see here on the right-hand side. In SAP HANA Cloud, we have wrapped the Cypher queries into an SQL table function like depicted here. It's called Open Cypher Table, where you essentially hand in the graph and the query that you would like to evaluate. And the nice thing about that is the data being returned is purely tabular, is purely relational again. And so from that Open Cypher Table function, you can easily join or relate to other data in your system, which may be not related to graph at all. Quickly about the built-in algorithms and the graph procedures, which is the stuff that you most probably will be using in order to solve the challenge. So GraphScript is essentially to your network what SQL script is to your relational data. So there are a set of graph-specific data types, graph, vertex, edge, there are paths, there are multisets, other container types, and there are basic operations that you can do on these data types, like, for example, evaluating the degree of a vertex, which means the number of incoming and outgoing edges. Then there are a set of built-in algorithms, for example, in order to evaluate the neighborhood. You can say, starting from that node, which other nodes are reachable within 4 hops, and you can get these reachable vertices, these neighbors of your starting vertex in a relational set, essentially. Then there are traversal statements which let you traverse starting from a start vertex in a breadth-first search manner, so level by level, for so to say, and doing some custom evaluations, custom logic while you're traversing the graph. The actual procedural logic encoded in GraphScript can be leveraged in either procedures, so database procedures. They can also be leveraged in table functions or anonymous blocks. Umang will later show you also an example for that. Here's how a GraphScript example looks like. So in this case, here's a function. We do have some incoming parameters. We do have a clause which tells what is the data structure being returned by that function. So the data structure returns, in this case, edges from that function. And then the actual body of this function starts with a begin, or is between begin and end. And here you see the syntax basically provided or supported by GraphScript. So you're instantiating a graph, you're calling a shortest path function, and then you are essentially outputting the results of these paths that you've just found. So this is the basic structure of a GraphScript procedural logic block. Maybe the last slide before I hand over to Umang. I just already mentioned that there are basically 2 workloads supported by SAP HANA Cloud when it comes to network processing. These workloads are pattern matching, which you usually do by writing declarative queries in Open Cypher language. And there is the procedural, more algorithmic type of workload for which we do support the GraphScript programming models. Both relate to the metadata provided by the Graph workspace. This is the thing that you need to create on top of your data in order to enable the Graph engine on your networks. The common layer for all of that is SQL. So all of that is integrated into SQL. And this is also the layer on how you can relate, how you can touch, how you can enrich your logic with additional operations, being it standard SQL aggregation queries or other operations like doing a full text search or evaluating spatial predicates. So the SQL layer is a kind of the binding layer which allow you to expose your graph capabilities and mix and match it with other relational operations which are supported by SQL. In the slide set, you find a couple of links to further information and resources. Let me just quickly show you what's in it here. There is a kind of public link list supported by Matthias Kemeter, where he essentially collects all the information related to SAP HANA Spatial. So there are overview presentations. There are some detailed descriptions on certain use cases. In a similar manner, there is a likewise page for the graph resources. Also here, a couple of introduction videos if you want to know more, a little bit about that Python interface and how you can use it to do graph processing in HANA from a Python perspective. And peeking into the documentation and looking a little bit forward on you solving that challenge that Umang will describe to you in a minute. There is a so-called graph script cheat sheet as part of our documentation, and this contains nice descriptions of all the building blocks of GraphScript. Here, for example, the graph algorithms, and for example, what you most probably will be using is some things like shortest paths here. Last but not least, there is that GitHub repository that Umang will also show you where the data resides and where you also will find the PowerPoint. So that's it from my perspective, and I will stop sharing and hand over to Umang.
Thank you, Markus, for this great overview. And now I'll start sharing my screen. I hope you can see my screen. So now if I talk about why you all are here, the community challenge. So meeting friends is always fun, right? Even it's more fun when you can do it at the comfort of your home, when they can visit you at your home. But what happens when your friend says, okay, today I don't have enough time, and do you cancel the plan or do you meet somewhere in between? I think if you choose the latter, then you are a good friend. And this is what also motivates a community challenge now. So what you see here is a map of the SAP's Waldorf campus. You see here, these polygons here represent all the buildings here. So the challenge that we propose is, like, now we are all back in the office. We are all now seeing our colleagues again. So you want to see your friend again. But the problem is that you both don't sit in the same building. So let's say that you sit in VDF 53, your friend sits in VDF 13, and now you want to meet, but you want to avoid that one of you has to travel all the way while the other one just sits in the comfort of their office. So the challenge is that you have to find a building in between so both of you can minimize the time traveled to reach that building. So do you need to go in this direction? Do you need to go in this direction? Would it be this building? Would it be this building? That's the challenge that you have to find out. Moving on to the next slide. So this is just reiterates what I just mentioned here. Some things to note are that basically these blue dots here represent the nearest street vertex. So these would be like a start and end point of this building. So you have to, this data is basically available in one of the tables that I'm just going to show next. And so this is the building here, which is in the data, it's called SAP building. And you have to find a path from Waldorf 53 and Waldorf 13 into one of these buildings, which basically is most time efficient or minimizes the distance traveled for both of you. And you have to keep in mind that this data is from OpenStreetMap network. So these buildings have a certain tag: commercial, office, yes, industrial. So basically the buildings that you need to take care of or you need to consider are the commercial, office, and yes. So basically you can't go to the industrial one here, which is the I think the data center, or there's also another one which has the link, the data center. So these are not the buildings that you can meet at. Then moving on to the next one. So this is basically the street network that you see here. The blue lines here represent the edges, and the red dots here represent the vertices, and the table is OSM edges, and for edge table, and the OSM vertices for the vertex table. And there's another table which is called SAP Building, which we just saw before. And these polygons here represent all these buildings. And these dots here you see are all the nearest street vertices that you see. And then there's a link to the GitHub repository that Markus just mentioned, but we will have a look at it now. And then we can actually head on to the demo, and I would share again the next screen. I hope you can see my other screen now. So this is the GitHub repository that we talked about. So here in the info folder, you see that there is just the PPT. So just in order for you to, if there's some confusion still, you can just have a look at the PPT again. And here in the data folder, there is a SQL starter script, and there is the zip file which contains all the data. So you could download this file basically, and then we are ready to see what we can do with this file. And now jumping to the Database Explorer, if you're not familiar with this or what it is or something like this, and there are some links that we have attached to the blog post, and I think it's also in the description, so you can have a look. So this is basically a Database Explorer which you use to query through the database. Once you have a HANA system or a HANA instance, then you can directly use this. You can load the database here with this plus button here, and once you have the database ready, then what you can do is right-click on the particular database, click on Import Catalog Objects, browse through, and you could see, then you can just directly import this file. So since I've already imported it, I won't import it again. I click on Cancel, but you click on Open. And then once you click on Open, you see the catalog objects here, which would be the 3 tables that we just talked about. Click on Import, and you have the data. And once you have the data, you can check if it's loaded or not with these 3 commands. It's just basically looking at the tables. This shows here the edge table. This one is the vertices, and this one is for the building. Let's look at the buildings table. As you can see here, this building shows all the buildings here in the Waldorf campus, and you could see like there are certain tags. There's like building, there's also kindergarten, there's hotel, there's data center. So you have to make sure that you don't choose one of these buildings. So it should be office, commercial, or ones with the yes tag. Then moving further in the script, this would help you create a graph workspace. So this graph workspace uses an edge table and a vertex table. You define a source, target, and key column from the edge table, and similarly a key column for the vertex table. Once you run this, you have a graph workspace loaded. And now let's see what we can do with this graph workspace table. So this here looks like a SQL procedure, and then this here has like an in and out parameter. So what is a procedure? It's kind of a unit which you use which encapsulates a certain logic inside, and the logic goes inside a begin and end block. And this here you see that okay, it has what you can do is that you can use a graph constructor to create a graph object, which basically references to the workspace that you created earlier. Similarly, you can use start and end vertex to have these vertices, the reference to these vertices. And once you have this, you can straight away call something like the shortest path algorithm, which basically takes like a graph, a start vertex and an end vertex. And this would return you a weighted path, which consists of basically the data about the nodes and edges. And this you can see like with here, we basically now load these vertices from this path and store them in this O vertices object. Similarly, here the edges of this path and load them into O edges. And once I call this procedure with this start and end vertex, we see that we can, there's the path with the vertices. So it's basically the vertices that are in this path and the edges that connect this path. And you see it's U and V. So U is here the source and V is the target. Similarly, if you are familiar with the table function, then you can use the table function, which follows the same logic. It's just you return a table here instead of out parameter, and then we just here return this particular table, which is basically the data from the edge table from the edges of these path. And then finally, there's also an anonymous block that you could use. It kind of also reduces the the code that you need to write. So here you just declare some variables here. You use the buildings to store. So basically, because you have a nearest street vertex in the SAP buildings table, so you could use something like this. So you don't have to look exactly which is the nearest street vertex. You could just write straight away this, and this would give you two vertices, which are the name here, which says, okay, the logic here says where name is like 18 or percentage 53%. So this basically filters out the buildings with these names. So this is also an easier way, so you don't need to really query through SAP building and find the specific nearest vertex. And once you load them here, you can just call them to this procedure, and then you select through the weight and the edges. And then once you run it, you see that, yeah, you see that there's always an target vertex, so basically the same data that we saw earlier, and also it shows what was the weight of the whole path. And with that, that basically concludes my demo that I wanted to show. And with that, I think we can jump to Q&A.
There are not a lot of questions right now in the chat, but could you share one more time the PowerPoint with the description of the challenge, just to make sure that we all have a full understanding of that?
Yes, I will. Can you see my screen?
Yep.
Oh, okay.
Yeah. Okay. I think it's worth mentioning that the data that we are providing for the challenge is essentially two sets. One is the street network, and the other data set is the SAP buildings. They can connect to each other because each building has associated the nearest street vertex. So if you're starting from building 13, you know where to enter the street network. And the second thing is, of course, we are searching, as you said, a building in the middle. We want to meet with the colleagues, and we both want to kind of walk the same amount of meters, so to say. And then as a third consequence, you cannot meet at every building. So in the industrial buildings, there is no coffee machine. There is no reason to go there. So we are looking for a building which is either yes or office or commercial. These are the buildings with coffee machines, so to say. So starting at two buildings, you need to leverage the street network in order to find paths on that street network that lead to a building. And that building somehow needs to be in the middle. There needs to be a fair share that you and your colleague need to walk. So that is the challenge. Give us the solution in terms of which building is in the middle and what's the path, or what is the distance from building 13 and 53 to that solution building. Okay.
Perfect. Thanks, Markus, for the summary again. I think that was helpful to, again, know exactly the prerequisites, and that it should be the equal share of a way to walk for both friends to meet in the middle. The blog post that the SAP HANA team posted is, as I said, in the description of the YouTube video here, but also in the chat already. Meanwhile, there was one question that came in. Two. So let's start with the Q&A officially now. Can you share more examples, like use cases and respective implementation with SAP HANA Graph for business objects coming from core SAP suites, SAP S/4HANA, SAP SuccessFactors?
Yeah, well, I would recommend to take a look at that specific resources website that I shared, and there a couple of use cases are described. asking specifically about business objects which come from SAP applications. I mean, I would say the most prominent use case is really traversing the bill of material or any type of production or supply chain. So traversing these type of networks in order to understand the impact if something fails, or the impact, for example, if in a data center some infrastructure goes down. So which machines, which applications, which processes are related to that. So I have to admit there is not a lot of slides out there which describes these kind of use cases, but think in very general terms about dependency analysis on bills of material, supply chain networks, and stuff like that.
All right, thank you. One more question from Paul here in the chat. Does Graph script support spatial data?
Yeah, good question. Essentially, Graph script has some limited support for data types. So we do not support each and every data type that you can work with in SAP HANA. So one thing is usually we do see that spatial data, just for example, the locations of a customer are kind of read-only data. So there is not really something that you can do from a graph logic perspective, but you would like to add that spatial data, that point geometry, that customer location to the output, to the result of, for example, your path, which you got from GraphScript. So essentially what you're doing is GraphScript supports a limited set of data types. You're running the GraphScript logic on top of your topology, on top of your network. And whatever you get out of that GraphScript program, you can use to join additional data which is hosted in tables. So correct answer is GraphScript does not yet support spatial data types, but it's very easy to attach geometries, join geometries from another table to result from a GraphScript program. And that's essentially what we also did here in order to create these screenshots that are still in share. So you can query, for example, for shortest path, and then joining street vertices and edges to that and plot that path as a type of a line string on a map. This is how you would do it.
Thank you, Markus, and thank you, Paul, for that interesting question. And then there is, first of all, there's also a thank you note here in the chat. I would like to mention that too in between. So thanks, Markus and Umang, for explaining everything. And another comment to the, I think it was to the question before, Markus, from Vladislav about different use cases and about the respective implementation with SAP HANA Graph and other SAP suites. Integration between SAP HANA Graph artifacts and Neo4j tools?
Yeah, unfortunately, no. I mean, what most people are looking for is a way to visualize the graph. And somewhere in that resources page, there's a link to a project where Matthias Kemeter wrote a plugin for Cytoscape, which is a rich client which can use to pull the data from HANA and bring into visualization. But besides that, specific Neo4j tools are not supported. What we do see is that interactive data exploration is, of course, very interesting if you're in a sales cycle, if you want to do demos, but the actual applications which leverage graph capabilities, most often they would require a real specific user interface, not a generic data exploration tool like you see from Neo4j, but rather a very specific application user interface, for example, where the planning guy in manufacturing can interact with the data and create some maintenance tasks. This is something that you can't do with generic tools. So straight answer, no support for Neo4j tools.
Thank you. All right. Vitaly asked the question, how to provide the answer to the challenge.
Susan,
I can answer that too, I guess. I know. So in the blog post, I read that to submit the answer to the question, you just have to email saphanacloud@sap.com. So it's all described in the blog post, how to submit the answer. And you also have to comment on the blog post that you accepted the challenge, because otherwise we don't know. It should be public, and everyone in the SAP community should know that you took part in the challenge. Yeah, but ultimately that to not share the result, obviously, email the SAP HANA team under saphanacloud@sap.com. And if that's incorrect, Susan, now it's the time to correct me. One more question in the chat here. Is there in your roadmap to deliver an SAP UI5 smart element to display a query graph workspace in custom UI5 application like in Database Explorer?
Yeah, also a good question. I mean, there are SAP UI5 controls that let you visualize networks. I'm not too sure about the roadmap of these visualization components. So blunt answer to that question is I don't know. Maybe no, I don't know.
Okay, maybe that's then a question for the SAP community, Michael, if you want to post it there, or we can follow up on that one to provide you with an answer.
Yep.
Okay, yeah, that would be cool. I also shared Umang's SAP community profile link in the chat, so you can follow our speakers of this call in the SAP community. And some time left for you. So it seems like, so if we don't have any questions left, I assume that everyone in the call here is knowing exactly what to do now to find the perfect route to meet with someone in Waldorf.
Maybe one comment.
And maybe
this is Jörg speaking. What I understood, the question, how to provide the answer will be, so the answer to that question will be provided in the chat so that everybody can see it.
The answer to the, say it again, is provided in the chat so everyone can see it, but then...
The answer to the question on how to provide the answer will also be posted in the chat on YouTube so that everybody can read it.
Right. Okay. Yeah. Got it. Okay, Shabana will take up on the button to make sure the assignment.
I can type in the answers that were given by Markus, so that it's recorded on the chat.
Perfect. All right. What I also want to share with you guys, let me type that in the chat as well. For our upcoming SAP community calls, please have a look at this link here. And the challenge, maybe that is also an interesting side note. The challenge is running for a month. So June 19th is end date. So you have some time, but don't take too long. We want to see a lot of submissions coming in sooner than later. And yeah, any more hints maybe from the team for the participants? Or do you think it should be all clear now? Anytime the community is there to post your questions. So the blog post, you can use that one to start a conversation with the community members on the challenge and double check on if there is anything that was not clear now from this call. But as you all know, the recording is directly available here in YouTube under the very same link that you're in now. So you can share that also with colleagues, friends, family, and re-watch and re-listen to what was shared.
Yeah, I would say if you're looking at the starter script in detail that Umang was also running through, it already contains a lot of parts of the solution, I would say. There are still some things to be solved there, but if you're stuck or if you're running into problems or having strange behavior in your IDE when working with GraphScript programs, then leave us a question in the community, and we'll take a look at it.
All right, perfect. All right, if there is no more questions, I would like to close this community call for today. So thanks everyone for attending, and thanks for taking the time. Thanks for the speakers, Markus and Umang, for taking your time and presenting. I hope to see everyone soon in our upcoming community calls. Maybe closing words from your end, Markus, Umang.
Yeah, well, thanks for watching, and I hope you take on the challenge, and I'm looking forward to the solutions you provide.
Yeah, thanks again for the opportunity, and yeah, same. I'm also looking forward to the solutions. Would be interesting to see.
Cool.
Thanks, everyone. Have fun with the challenge.
You do. Bye-bye.
Thanks a lot. Good luck.
Bye.
Bye.